Kia ora tātou, ladies and gentlemen. No mai ki tēnei rā mō tu hake mō te Liggins Institute me te whare wananga o Tamaki Makaurau. Good evening and welcome. It's my pleasure to invite you here this evening. My name's Professor Frank Bloomfield and I'm Director of the Liggins Institute. And welcome to our last public lecture for 2018. Although I hasten to reassure you there will be more next year. So before we get started, just the usual health and safety announcements. If there should be an emergency, then red lights will go off and sirens also. And please evacuate the lecture theatre either by the doors at the back that you came in or the two doors at the front, and exit the building through the main entrance and accumulate in the square out the front there. Bathrooms are located either to the right as you exit the lecture theatre or directly across the atrium. And please do turn off your mobile phones. So today's evening lecture is Brain Health in the Baby Born Early. Preterm birth is a major public health problem. Around the world there are about 15 million preterm babies born every year, and the rate is increasing. In New Zealand it's now 7.6%. 30 years ago it was 4.6%. Over that period of time, the survival of preterm babies has increased dramatically due to advances in obstetric and neonatal care. And perhaps the most dramatic of those advances was the discovery of antenatal glucocorticoids for the maturation of the fetal lung and also the capillary network in the fetal brain that protects these babies from intraventricular hemorrhage, which of course was discovered by Professor Sir Mont Liggins, after whom our institute is named. So now that survival has improved so dramatically, our attention is turning more and more to ensuring that the survivors of preterm birth have a healthy and productive life, and particularly relating to their neurodevelopment. Very preterm babies born 2 months more or earlier have the highest risk for neurodevelopmental problems as they grow. However, we do now know that even babies born just a few weeks early also are at increased risk. Here at the Liggins Institute, we're undertaking a series of studies into the nutrition of preterm babies in the first few days after birth to see whether the nutritional strategies we employ can improve their lifelong health. And more recently, we've started to collaborate with Professor Stephen Miller, who's our speaker this evening, a neurologist from Canada, into how nutrition in the very first days after birth may also impact upon the developing brain. Professor Stephen Miller is visiting Auckland at the moment as a University of Auckland distinguished visitor. And in his lecture this evening, he will explore the dramatic period of brain development that occurs in babies born preterm through their medical care in a NICU. He'll examine how our understanding of brain injury in the baby is evolving towards a greater appreciation of how even everyday events in the NICU might have an important impact on later outcome for these babies. So Stephen is a pediatric neurologist who spends most of his time in the neonatal intensive care consulting on preterm babies. He is head of the Division of Neurology and the Centre for Brain and Mental Health at the Hospital for Sick Children in Toronto, and also professor in the Department of Pediatrics at the University of Toronto. He holds the Bloorview Children's Hospital Foundation Chair in Pediatric Neuroscience and recently served as the president of the Society for Pediatric Research, which is the US's major academic pediatric society. He's passionate about supporting the career development of child health researchers, and this afternoon spent, I think, a very productive hour or more with some of our PhD students just chewing the cud and giving them advice about their future careers. He now co-directs ChildBright, an innovative pan-Canadian network that aims to improve life outcomes for children with brain-based developmental disabilities and their families. So it's a great pleasure to invite Professor Stephen Miller to deliver this evening's lecture. There will be the opportunity for questions afterwards, but I do ask you just to wait until the microphone reaches you so that everyone can hear the question as well as Stephen. Thank you, Stephen.
Thank you. Thank you for the kind introduction and the exceedingly warm welcome I've had from the entire Liggins team and the community of people that I've met in Auckland and the University of Auckland. So this evening we're going to look at brain injury and development in babies that are born too early, babies that are preterm. And I also want to thank and acknowledge the many of you who have shared your stories of connections to babies that have been born preterm and the experience you've had either caring for these babies professionally or personally. So to help me get to know you a little bit better, I have a few questions to ask. You'll forgive me. So I see many young people. Can I ask how many people here are students or trainees? Great. How many people are in healthcare? And how many people are parents? Super. How many people here were children? Good. So if you leave here sharing my wonder about the child's brain, I will have done my job. So to get us going, thinking about neurology, I want you to imagine that we are now going to walk over to the Auckland hospital. You're coming over with a neurologist, and I tell you that we're going to go see a patient with stroke. Close your eyes for a moment and picture who you think we're going to meet. Now I'm going to ask you, at what time in your life is one most likely to have a stroke? Show of hands for newborn, child, an adult? How about the elderly? So this is the best audience that I've ever had the chance to meet because there are actually a few people here that put their hand up for newborn. The day you're born is the single highest time in your life at which you're going to have a stroke. And for most people, that comes as a tremendous surprise that babies have brain injury. And for many years, we thought of the baby brain as being sort of invulnerable. But we're now appreciating that the baby brain is actually something that we need to pay more attention to so that we could foster its development. And one of the ways we've done that is by shifting the focus of newborn medicine towards what I'll call neonatal neurocritical care. So the critical care of the baby brain. Shown here is the unit that I work at the Hospital for Sick Children. And you could see many of the incredible medical advances that have been made over the last decades. Things like brain monitoring and cooling. And I show you this cooling in particular to acknowledge one of the other tremendous contributions of the Liggins and the University of Auckland to our care of babies, where brain cooling is now used to treat babies who have had a lack of blood flow at or around the time of birth. And it's an incredible example of how research advances could be brought to transform care of the vulnerable child. But this evening, we're not going to focus on the full-term baby. We're going to focus on the preterm baby. We'll call her Sarah. And I show her picture to be sure that everything we talk about for the remainder of this evening, I'm going to show you lots of brain images, but it really is about the baby. And I show you Sarah to highlight a few things. The first is to show you that she's small, she's sick, and that in modern intensive care of babies born preterm, we manage to monitor everything. You can see that the breathing is being supported by a tube attached to a ventilator. We've got heart monitors, breathing monitors, saturation monitors. But notice the absence of monitors on the brain. And as a pediatric neurologist who cares for babies, there's not a single parent that I meet that doesn't ask, what's going to happen to my baby's long-term development? And will my child thrive? And so this is where we are and what I think the room we have to change. Now, for the many students that put up their hands in trainees, I have to say that in 2018, you are so lucky to be training at this time, where we have all of these new incredible technologies that give us these unbelievable windows that would have appeared science fiction and not that long ago when I was training in neurology, that are allowing us to ask questions of how can we support this vulnerable brain. Now, we heard from Frank earlier why this is such a key issue. The rates of preterm birth are rising internationally. In Canada, more than 1% of live births in our country are born very preterm. That is at least 2 months early. So if full-term gestation is 40 weeks, we're going to focus this evening on babies that are born 24 to 32 weeks gestation. So quite a bit early. The reason that matters so much is that despite modern intensive care, 10% of babies born at these ages will come back to the neurology clinics with diagnoses such as cerebral palsy. And half of these babies will come back to us with concerns about their cognition, their thinking, their language development, and very important parents, their behavior. So I've been asked to give you some disclosures. I unfortunately have no financial disclosures. I feel compelled to say that I'm from Canada. And much of the work that I'm going to share with you this evening comes from my time when I was in Vancouver, a beautiful part of the country that reminds me a lot of being in Auckland, by the water, great sailing harbors, and wonderful, I'd say wonderful people. Almost 7 years ago, I moved to Toronto, which is, well, on Lake Ontario, is a wonderfully dynamic cosmopolitan city of almost 5.5 million people, and the home of the Hospital for Sick Children, where I showed you that neonatal intensive care unit. And in my role leading the Center for Brain and Mental Health, I would characterize my job as trying to foster the integration of clinical care, research, and education. So I hope you get that message as we walk through this. So I do have to disclose, when it comes to finances, that I am passionate about child health research, and I also think that there could be no greater investment that society can make than understanding how to better care for our children. And it's not just an emotional argument, it's a financial argument. This is a study I love from a former colleague at the University of California, San Francisco, Claiborne Johnson, who's now dean of a medical school in Texas. And at the time that everybody was talking in the United States about the silver tsunami, and all of the attention of federal funding agencies were going to the aging population, Clay wanted to ask, what was the impact of studying brain diseases? And what was the return on investment for investing in clinical trials that would test how to better care for this population? So the National Institutes of Health is the US federal funding agency, and again, I'm Canadian. They invested in 28 clinical trials. That's about as, there's probably more trials going on than the Liggins today. But when the study was done in 2006, they had completed 28 trials. 6 of those trials had improved health, and 4 of those trials had enough improved health to have cost savings to society. So they invested $335 million. They saved, in societal terms, $15.2 billion. So why is that so impressive? Is that half of that cost savings was by a single trial, and the only trial in this whole portfolio that focused on babies. So child health research matters. The other evidence that I'm going to show that has nothing to do with babies, and I promise we're going to come back to the preterm baby shortly, is this study, which completely changed my view of what I do as a clinical researcher. This is from Maria Brito, who has preceded me as president of the Society for Pediatric Research in the US by a couple of years. She's a health services researcher that focused on children with cystic fibrosis. She addressed the challenge from a health services perspective of how do we bring research advances to the point of care. Now, for people that were active in the medical sciences in the mid-1990s, you would have recognized cystic fibrosis was the disease for which there was a promise of gene therapy. Gene therapies were going to cure cystic fibrosis. We're still waiting. Stem cell therapies was the next promise for cystic fibrosis. But the group of philanthropists and researchers at the Cystic Fibrosis Foundation said, we can't wait for these big bang therapies. We have to start looking at what we do now. And so they made it a condition of funding that each of their centers had to reach certain benchmarks. And they had to take what was learned from the research studies and implement them in clinical care. So what happened? In 1994, if you were born with cystic fibrosis, your survival would have been 27 years. In the 5 years afterwards, it would have been close to 28.5 years. They then started a quality initiative and then tied funding to this initiative. And all of a sudden, survival went up to 37 years. No gene therapies. So how do we look at how we care for babies with what we have at our disposal to have the same advances that they've seen in cystic fibrosis for the developmental outcomes that matter so profoundly for the families of babies that are born preterm? Now, as a Canadian, to recognize some pioneers in Canadian medicine, This is a picture of Fraser Mustard, who really built the hypothesis in Canadian medical sciences that early life experiences shape the health, learning capability, and social functioning of our children throughout their lives. And so he put the emphasis on a child's start in life predicting a trajectory of development. And I disclose this here because you're going to see that this is the theme of what we're seeing in the babies, that brain health in the newborn really characterizes long-term changes in brain development. And the other person to acknowledge is former US President Barack Obama. I love this quote, that as humans we can identify galaxies light years away, we could study particles smaller than an atom, but we still haven't unlocked the mysteries of the 3 pounds of matter that sit between our ears. Now, if we think about those 3 pounds, the brain, there are a few 100 billion brain cells that we're going to call neurons. These are the core elements that, if our brain were a computer, they are the computer chips. And these billions of neurons make a trillion connections. The only reason we're all here tonight is because of our brains. Our brains really make us who we are. And so the question we have as clinicians and scientists is, how do we foster those hundreds of billions of neurons to form the trillions of connections as effectively as possible? So to help us think about the brain, I'm going to suggest we think about the brain as a circuit. We've got the brain's macrocircuits, or the brain's information superhighways, that are shown illustrated in this magnetic resonance imaging picture that shows how the tracks in the brain, those information superhighways, connect. Now, those superhighways, just like in our cell phones, those highways have to be insulated. Now, our computer and our cell phone pathways are insulated by plastic. The brain insulates these fibers by a fat that's called myelin. Now, the tracks are just the connections, so we need the cells that are going to now form the connections. I've mentioned the billions of neurons that we have, and we have even more glial cells. The glia are the supporting cells of the brain. And people used to look down, neuroscientists would look down on people that studied glia biology because neurons were like the sexy cells. And so you wanted to study how these cells form their connections, but they only work if they're supported by glia. And it's glia, in particular the oligodendroglia, long name, but glial cells is what forms the myelin that insulates the fibers so that the neurons work properly. Then we can think about nanocircuits, chips and components or transistors, and those are the biochemical pathways in the brain. And so we're going to drill down at each of these levels at brain health in the preterm baby. So with those as my disclosures, what I'm going to suggest is that with the improvements in mortality and survival that we've seen in the baby, the main challenge to child health now is how do we ensure that this baby born preterm develops as optimally as this baby born full term. So let's now come back to Sarah, our baby born preterm, and look at her brain. This is an example of magnetic resonance imaging. So it's a non-invasive imaging test that we can use to look at the baby brain. There's no x-rays or radiation. And these are images as though we've taken off the skull and we're looking down on the brain. So shown here in dark, this dark ribbon, this is the front of the brain over here. This is the back of the brain. And look at this dark ribbon. It's about 1 millimeter thick, just to give you some context of scale. And this is the cerebral cortex. This is the part of the brain where all of these neurons live. The white matter here are the connections, and it's bright because it's filled with water. And early in the 3rd trimester of gestation, it's not yet myelinated, so there's no fat, so it looks bright. The thalamus and the basal ganglia are the brain's relay stations, more neurons. So computer chips on the surface and in between, and all of these pathways that ultimately have to get insulated by the fat called myelin. These are images from a baby that was born at 28 weeks gestation, 3 months early, scanned with MRI at 30 weeks or 2 weeks of age, and then the same baby brought back to the scanner at 9 weeks later, so just before her due date at 40 weeks. And we can't do these studies without the tremendous support of families who are participating in them at really stressful periods of time. In Vancouver, many of these families It meant coming back from long distances to the city. So we are incredibly indebted to them for their help to look at how the brain has changed over these 9 weeks. So now this cerebral cortex, these billions of neurons, are now lumpy bumpy, sulcated and gyrated in 3 dimensions. It looks like our brains, that crenulated lumpy bumpy surface that we have. Why did it fold in like that? Well, it folds in because these billions of neurons making their trillion of connections need space. So it can't grow out, so it grows in and gets lumpy bumpy. We start to see fat, myelin, in the posterior limb of the internal capsule, a long way of saying in the connections of our voluntary motor pathways. So while the brain is growing like this, we see the baby is starting to move much more because those pathways are becoming much more efficient. Now, this incredible transformation of the brain is happening over the period this baby is receiving intensive care. This baby spent 6 of these 9 weeks exposed to neonatal intensive care. And so when we think about brain health in the preterm baby, we used to be focused on the big events like stroke. But we now appreciate that we really need to think about the everyday. We need to think about how is this incredible process of development occurring, and what are the everyday experiences of these babies that are impacting how this brain is developing. So let me give you a picture of what brain injury used to look like. This is an ultrasound image, and is still the technology we use to image the baby brain routinely in clinical practice. We do that because it's safe, and we can bring it to the NICU, as opposed to for MRI scanners. In most centers, we have to bring the baby to the MRI. But it does look a bit like one of those old, out-of-focus black and white TVs that couldn't quite get the signal. And that's what the white matter should look like. It just looks like this. This is the front, so the nose would be about here. This is the back of the head over here. This dark are the normal fluid-filled spaces in the brain called the ventricles. This is normal white matter, and in this baby we have all of these cysts, all of these small strokes throughout this baby's white matter next to the ventricles. We've given it a long medical name. We've called it periventricular leukomalacia, or PVL for short. Peri because ventricular, because peri is near the ventricles. Leuko, it's in the white matter. And malacia because the white matter is soft. It's too soft here. Baby brains don't form scars. The tissue just dissolves once it's been injured. As a pediatric neurologist, this is the lesion that had been our focus because babies with this lesion would come back to the neurology clinic with a special form of cerebral palsy, vision issues, and cognitive or learning issues. But we've learned over time that this lesion is disappearing. So if we look at the experience at the University of California, San Francisco, from 1992, in babies born very preterm, 24 to 32 weeks gestation, the incidence of PVL was 2%. By 2002, it was 0.2%. Just like cystic fibrosis, there was no big bang brain protection strategy. There was no gene therapy or stem cell therapy. This decline was strongly associated with more general use of mechanical ventilation. So something that's done every day in NICUs is we support babies' lungs. I showed you that picture of the preterm baby getting support for her lungs with a ventilator. Using that more optimally, we see this dramatic decline in the occurrence of the most severe form of brain injury. So what else could we do to prevent this decline? I'll say that this finding has been replicated elsewhere. So it's not just San Francisco. Linda DeVries and her team at Utrecht have seen the same decline, and they were able to follow their children long enough and well enough to show that their burden of cerebral palsy also decreased. But using MRI, we now recognize a different spectrum of brain injury, and I'm going to call it white matter injury to keep it simple. But it looks just like PVL. It's just less severe. It's next to the ventricles, and it's in the white matter. And we only see it with MRI. We see it with MRI particularly early in life. So this is a different type of MRI scan. Same scanner. It's acquired around the same time as the other images. We could see the cerebral cortex is bright. The white matter is dark on this sequence. The cortex is relatively smooth, so we know the baby's preterm. The white matter should look gray. But instead, you've got all these white spots, these small little strokes in the white matter that just aren't big enough to form those big cysts or fluid collections. Now, this isn't a new problem, but it's invisible more or less to ultrasound. So this mom, volunteered for our studies, telling us that you need to see a baby doing well. Don't just focus on brain injury. And my baby's ultrasounds were normal, so you need to scan her. And so we were very surprised, really dismayed to see that there was a significant degree of brain injury. So we brought her back to the NICU, brought the ultrasound machine back, and you just don't see it. And this really worries me as a clinician because this is the test we do all the time. And so we're now transitioning to do this test more often because this is the window that we need to better guide how to care for these babies in the longer term. Now, about 1/3 of preterm babies will acquire this spectrum of brain injury. So we really have our work cut out for us to care for babies in ways that prevent this brain injury from happening. Now, why is the white matter in the preterm baby so vulnerable? This is a slide I used to summarize about 20 years of work by a friend and colleague, Stephen Back. He's a neuroscientist and pediatric neurologist at Oregon Health Sciences University. He started with Joel Volpe's group, and he's well connected with the University of Auckland group here. And what Stephen has shown is that the white matter is so vulnerable because the cells that live in the white matter in the 3rd trimester of gestation are exquisitely vulnerable. So let me say that again. The white matter, those connections, the vulnerable area, is injured so often in babies born preterm because the cells that live in the white matter at that stage of brain development are exquisitely vulnerable. So I told you about the fat that needs to be laid down for effective brain transmission, myelin. Myelin is made by glial cells, and it's made specifically by these beautiful cells called oligodendroglial cells. The oligodendroglial cells start to differentiate, and they pass through these very specified phases before they lay down fat as a mature oligodendrocyte. Unfortunately, the pre-oligodendrocyte is exquisitely vulnerable to injury. We used to think that with any sort of energy deprivation, drop sugar levels, drop oxygen levels, these cells in the white matter would die. The immature oligodendrocyte, as it starts to associate each cell with hundreds of axons and starts to wrap around them and then lays down fat to insulate the nerve fibers, these cells are really hard to kill. If you look at a baby that's born full term at 9 months or 40 weeks gestation, you sometimes find white matter injury, but not really. The white matter there is filled with these cells. But if you look at the brain of a baby that is 28 weeks gestation, that white matter is filled with these pre-oligodendrocytes. And we operated on, for many years, on a model that these cells were vulnerable and they were lost. And it wasn't really a hopeful model. Stephen Back has since come along, working with people like Justin Dean, who are now right next door here at the University of Auckland, to show that, in fact, in the broadest spectrum of white matter injury, the pre-oligodendrocytes actually get upregulated. You have too many of them, but they fail to mature to become normal myelin-forming oligodendrocytes. So the focus now isn't what do we do with the lost oligodendrocyte? It's how do we unstick these pre-oligodendrocytes to allow them to progress normally. And Stephen Back's lab has some very recent new exciting avenues about how to unstick these cells in their development. But let's take a look at MRI. To do MRI scans in the fragile, young, small baby, we need to rely on specialized equipment. I'm showing some pictures of that just to give you a flavor for what's involved to bring a small baby to an MRI scanner. These are MRI-compatible incubators that provide a thermo-regulated environment. So a lot of this is heating, oxygen, air, mechanical ventilator. You can see at the tip over here. The baby is swaddled and put into the scanner, special ear protection so the baby could sleep, just have natural sleep through the MRI scan. And we have dedicated MRI equipment just for the baby brain that surrounds the head over here. And the baby then slides right into the MRI scanner. And what this has allowed us to do is not only scan babies safely at early stages of their lives, but also to move from the beautiful pictures I showed you of the brain to now being able to quantify brain development. So this is the same baby I showed you, born 3 months early, scanned at 30 weeks, so at 2 weeks of age or 30 weeks gestation, again 9 weeks later. And notice how the white matter just looks bright. We get a bit of myelin, the fat, in our voluntary motor pathways over here, but otherwise the white matter just looks kind of the same. But if we now use new quantitative imaging tools that give us the brain's microscopic structure, the microstructure, we can now delineate specific fiber pathways within this white matter. So here we've coded water that's moving in the brain right to left as red, so we can make out the main connections of the brain, the corpus callosum. Front to back in the brain, we start to see the primary vision pathways going from the thalamus, the relay station, all the way to those nerve cells in the cortex, the primary vision cortex. Look what happens to this pathway in green. You can barely make it out at 30 weeks, and at 39 weeks, you've got this beautiful, robust pathway. Before there's myelin, we still see some pathways that are voluntary motor pathways, but look how much better we see them over here. And all of this for clinicians fits because we see babies moving more robustly, we see them starting to fix on faces, and if you've got a red piece of yarn, babies love to look at them when they're at this stage of development. So we can map out this incredible period of brain development, not just in pictures, but each little dot that makes up this image provides us quantitative information about how the brain develops. One parameter, it's got a terrible name, but I'm just going to tell it. It's fractional anisotropy. It's a scalar. It goes from 0 to 1. It doesn't really matter what it is, but the higher it is, the better it is. And as these white matter pathways mature and myelinate, fractional anisotropy goes up. So we can plot fractional anisotropy. We could plot the age of scan. And this is from a group of 200 babies born preterm in Vancouver, where we followed them out at this stage to 18 months, a year and a half of age. We use a standardized test of development that's called the Bailey Scales of Infant Development 3. It's a mean and average score of 100, standard deviation of 15. So scores less than 70 would be a clinical concern. We could see that the babies with the scores that are concerning to us, their white matter just isn't developing. And it's not developing beyond those pictures of those little spots of white matter injury. So the challenge ahead of us is now, how do we make sure that all of these preterm babies develop along this trajectory? There are many things in a baby's intensive care that will impact their brain development. We heard of the pioneering work done at the Liggins on neonatal nutrition and how we could support babies' growth and brain development through nutrition. We know that infections are a concern for the baby brain. I know that there are a few neonatal intensive care nurses who I'm sure pay a lot of attention to infection control. How many times do we wash our hands? What we should be asking is, how are we protecting the brain from our infection control strategies? Less infections, less white matter injury. Pain, we're going to look at in a little bit more detail this evening, and then medications. So let's get to the importance now of the everyday. Unfortunately, if you were born preterm and are in an intensive care unit, there is no more daily experience than pain. When we looked at a group in Vancouver that was born early, 24 again to 32 weeks gestation, in a NICU that's been attuned to pain for many years, the average number of pokes that a baby will undergo is about 110. Right? That's like all of us having had a blood test before the glass of wine and maybe coming back for another one after the lecture and doing the same thing again tomorrow. Now, I moved to Vancouver and got very lucky to have a colleague in developmental psychology, Ruth Grunow, who studied pain for decades. And Ruth had shown that the number of times a baby is poked was a very strong predictor of how well he or she will do in her cognitive development, her behavior, and ultimately, longer term, her mental health. And so if your cognition and learning is altered as a neurologist, there has to be something different in your brain. So working closely with Ruth, we wanted to map out how does neonatal pain, that experience of painful procedures, map to this incredible period of brain development. And it really, for me, this was also a lesson in getting colleagues outside of neurology who think about things differently. I never in a million years as a neurologist would have thought I would have become a pain researcher. But Ruth took a very pragmatic approach to pain, which wasn't to infer what a baby was feeling. It's very hard to know. She just counted the number of times something painful happened. Now, what we see is that the number of times you were poked as a baby born preterm, the slower your brain develops. And the slower it develops on every measure we could think of. Your microscopic structure of white matter pathways, your biochemical pathways, which we can also measure non-invasively with magnetic resonance spectroscopy, and your brain volumes. And before the lecture, I had a chance to speak to a few of you, and we were talking about mentorship. And I've been very fortunate to have phenomenal mentors, and I count on them to ask the very hard questions. And for many of them, at least my mentors, the idea that pain would be a problem for the baby brain was unbelievable. Now, the part of the brain that receives all of our sensory information is the thalamus. The thalamus is one of those relay stations I had mentioned where all of these neurons, where some of these neurons live, and then they project out to the cerebral cortex. The thalamus gets information to where it needs to be. So one of my mentors, Donna Ferrero, is one of the pioneers in neonatal neurology at the University of California, San Francisco, said, if pain is so important, then show me some change in the thalamus. It's this area right over here. Now, the thalamus is important for all of our sensation, including hearing and vision. It integrates information that just comes in a circle from the cortex. So it's not just about what we feel. If you touch your hand, that's traveling up your spinal cord, through your thalamus, to the top of your brain in the cortex, and it says, someone's touching me. So we spent a number of years trying to refine how we measure the thalamus growing and how we look at the shape of the thalamus. And what we've recently found, this is work by Jessie Guo and Emma Dordan, a research associate in my team and now faculty at the University of Western Ontario, is that the more times you're poked, the smaller your thalamus, smaller right in the sensory area of the thalamus. So the vision area would be back here. It doesn't touch that. So more pain, thalamus size, smaller, particularly in sensory thalamus. And it doesn't predict as strongly other parts of the brain, suggesting some specific relationship between pain and the early developing brain. Now, we don't just let babies have pain. I should say that when I was training as a pediatrics resident at the Montreal Children's Hospital, some of our NICUs, we still debated whether the preterm baby actually felt pain. We now recognize that babies born preterm feel pain. We now have evidence that pain may not be good for the brain. And we treat pain with analgesics and sedative medications. Across NICUs, I haven't gone to two NICUs where we treat pain exactly the same way. In Vancouver, we used a medication called midazolam. Midazolam is a benzodiazepine medication related to Valium or diazepam, Ativan, lorazepam, commonly used medications for sedation and anxiety. And there was some suggestion from the neuroscience literature that midazolam was bad for this part of the brain, the hippocampus, the part of the brain, beautiful part of the brain that stores memories. It's called the hippocampus because it looks like a seahorse. Small little structure. If you remember anything from this evening, good or bad, it's stored in your hippocampus. So the hippocampus undergoes an important period of development over the time of newborn intensive care. And I landed up in Toronto to a NICU that told me that we have a ban on midazolam in babies that are born preterm. So that motivated us to try to map out the hippocampus. Now, the hippocampus is a small area, and I don't want to leave you with the impression that you could just put a baby in an MRI scanner and get the answers. There's a tremendous amount of work that goes on behind the scenes with physicists and engineers to try to make this mapping as good as possible. This is an example of what was required to map out the hippocampus. It took someone a painstaking amount of work to color in the hippocampus of about 15 babies twice. So that's almost 6 months of work for one of our postdocs. And then working with Jessie Guo, an MR physicist, now research associate, and Malar Chakravarti, an imaging scientist from the adult world, we adapted his tools to now allow us to segment the hippocampus in a few hundred scans. Taking these segmentations, which give us this beautiful three-dimensional picture of the seahorse of the hippocampus, Emma Durden was then able to ask, how does hippocampal growth relate to how much midazolam you had? And the results were fairly surprising in that the more midazolam these preterm babies were exposed to, the slower the growth of the hippocampus, even when you account for how sick babies are, how much other medications you have. Now, I should say that we don't just use midazolam. We use narcotics like morphine. It doesn't predict the hippocampus. These babies are on the sedative medication because they're often on a ventilator for a prolonged period of time, or they have infections. This relationship was quite specific to midazolam and has allowed us to relook at how we use this medication in the baby born preterm. Around the same time, we were understanding that morphine may be similarly toxic to the large, beautiful neurons of the cerebellum called the Purkinje cells. Emily Tam and Jill Zwicker, I'm sorry, their name got cut off at the bottom, refined how we measure the cerebellum, this structure in our hindbrain, the back of the brain, very important for how we move and how we learn motor skills, to show that the more morphine you were exposed to, the slower the growth of your cerebellum. And so we're now left needing to ask, how do we provide analgesia, not just in a way that improves the subjective experience of pain, but how do we treat babies' pain in ways that promote optimal brain development? And we're doing that by looking at a new group of babies that are born preterm across these NICUs in Canada with very different pain management strategies. So I'm really hoping to get invited back when we know a little bit more about what's better for the brain. What we are confident in is that preventing pain has to be one of our priorities. Now, we heard a little bit earlier about the importance of nutrition. And there's no doubt from studies that were led by the Liggins that nutrition is critically important for how the brain, how the young developing brain grows. Why don't we look at nutrition, though, as a potential brain protective strategy? So these are data from Julianne Schneider, a wonderful young neonatologist in Lausanne who came to spend 2 years with us in Toronto. And she brought brain imaging data from a group of 50 babies that were born preterm, that were studied early in life, prior to term age, and then again at their due date. What was special about this NICU is that they used no midazolam and very, very little morphine, and they paid a lot of attention to nutrition. And Julianne was painstakingly able to go over their records to characterize their nutrition over the first 2 weeks of life. Why did we focus on the first 2 weeks? Well, because people at the Liggins taught us that if we just had to look at the first week, it was that first week that was so important for nutrition early on. Now, Julianne, as a neonatologist, was very interested in terms of how do we provide support with a mechanical ventilator to support the young lung that we know is improved by antenatal steroids, but not perfectly. So many of these babies need to be on a ventilator for a period of time. And what Julianne showed is that the longer you're on a ventilator, high ventilation needs, the slower your brain is growing. But if you're on a ventilator for a long period of time and you get a high caloric intake, you don't see that relationship, suggesting that if we doubled our efforts on nutrition for the babies on a ventilator, perhaps we could mitigate the adversity related to ventilation. So the question we're left with, this isn't a randomized trial. We haven't proven that better nutrition will protect the brain, but it certainly is a tantalizing question for us to go after now, is how do we use nutrition as a brain protection strategy? Remember the great improvements they had with cystic fibrosis, just with everyday incremental improvements in clinical care. Can we lower pain in ways that protect the brain? Can we improve nutrition for babies where the brain development is vulnerable? So where do we go from here? One way is to look farther. And I say that brain health is child health because this is the same baby that was scanned at term and is now brought back to the scanner at 8 years of age. And the brain has undergone yet one more complete transformation. So here, look at the cerebral cortex. It's still lumpy bumpy, but now it's bright, and the white matter is dark, because on this sequence, fat is dark. So now the brain is fully myelinated. I mean, it's been one of the great privileges of the job is to get to know these families over this time and see their children grow up. But nothing really prepares you when you look at these babies at just how dramatic and incredible a period of brain development is happening over this time. And it continues after they leave the NICU. So what about the home environment and socioeconomic status? And this is becoming a real focus of our team. Because we know that a children's vocabulary, how many unique words you have when you're 3, is an incredible predictor of success in life. Not just academics, but life overall. If you look at a child's vocabulary at 3 years of age, in a high socioeconomic status group defined by maternal education, it's about 1,200 words. Middle SES, 620, low SES, 580. This is a classic study by Hart and Risley that often appears in the New York Times. And there's a half a vocabulary difference as you go from a high SES group to a middle SES group. So it's not just about extreme disparity in poverty. There is a dramatic change in children's outcomes based on socioeconomic status. In many ways, this dwarfs the issues that we think about in medical care. It doesn't just happen. There's a biology to this. Kim Noble, psychologist at Columbia, scanned 1,099 children and youth, young adults, in LA County and shows that how well developed your cerebral cortex is, those billions of neurons making the trillion of connections, is highly related to years of parental education and total household income in those areas of the brain that are most responsible for language development. I don't think that socioeconomic status is a fixed construct. When we look at the Vancouver babies, this is work by Jill Vinal, a PhD student with us, now a postdoc in Calgary. When she looked at the number of skin breaking procedures relative to internalizing behaviors, here, higher scores is not what you want. Higher internalizing scores here means more anxiety, less attention issues, or more attention issues. You see, as Ruth has shown before, that these behaviors increase the more skin breaks you have, unless there is a more optimal mother-infant interaction. So how do we now look at our neonatal follow-up programs to not just measure the child's outcome, but to support an optimal mother-infant interaction to try to mitigate the early adversity that these children might have gone through? Isabel Benavente Fernandez is a neonatologist from Cádiz, southern Spain, who spent 1 year with us, originally focused on ventilation and the brain. But she went back to a NICU where the unemployment rate for women of childbearing age and men of men of parenthood was 50%. They don't yet bear children, so excuse me. So she shifted her focus to look at socioeconomic status. And what she sees, if you look at these children from Vancouver, so again, Vancouver, a very high resource setting like New Zealand, single-payer healthcare system, easy access to medical care. Their full-scale IQ is shifted way over to the right if your mom had a postgraduate education. Not much different if your mom had an undergrad education or high school education. So very consistent with the Hart and Risley data. But instead of focusing on the disparity, why don't we focus on what's happening right at this end of the curve? Similar changes with motor function, just a little bit less pronounced on the graph. So Isabel took this a step further. She plotted your IQ of the cohort based on mom's education, postgrad, undergrad, high school. So you notice first, higher outcomes, that's that right shift to the curve with postgrad education. But she then split the group into those with and without brain injury. Brain injury, dotted lines, no brain injury, solid line. Notice that in this postgrad education group, it doesn't matter if you have brain injury. Notice how pronounced the difference is. It's almost half a standard deviation different if your mom has a high school education. Similar spectrum and severity of brain injury. What's happening to protect the brain here? What are these families doing that mitigate the impact of early adversity? I don't have an answer, but I will have to come back, I hope. To try and get at these issues, become very interested in trying to understand better what are the questions that really matter to families. As part of Canada's strategy for patient-oriented research, there's been an effort to engage parents and youth in the research process, not just as participants, extremely important, but as active collaborators and partners in the entire research process. ChildBright is a national network that links all of the children's hospitals in the country. And we fund 13 first-in-human clinical trials with a research agenda that was set up in collaboration with families and youth as partners. We focus on children with brain-based developmental disabilities. We have 3 themes. One focuses on how do we enhance early brain development, because parents of young children came to us and said, you know, how do you solve this issue? How do you help promote early brain development? Parents of slightly older children said, much to our surprise, the IQ scores I showed you here didn't really matter so much to us. We want help with our children's behavior. So we have several trials that are focused on improving children's behavior. If you look at the literature for a drug commonly used in Canada for attention deficit disorder, Ritalin, it's never been trialed in children that were born preterm. They were often excluded from the studies. So we're not testing Ritalin per se, but we're testing other strategies, pharmacologic and otherwise, to help with behavior. And other families were really stressed by navigating a complex healthcare system. And I think we'd find a lot of similarities in the New Zealand and Canadian systems, particularly around transitions from the NICU to going home, preschool to school age, and from the end of pediatric care transitioning to adult care. I thought I had the website up. Some of my text is disappearing. It's child-bright.ca, and I'd invite you to have a look, and particularly at how we've been engaging families, because to my knowledge, this is the first systematic effort to get parents and youth engaged in the research process. So let me come back to James Heckman. His name is gone too. He's a US Nobel laureate. And what he showed is that if one looks at a societal level at the returns to $1 invested, there is no question that the greatest investment we can make is in the early years. For every dollar invested in those first years of life, the rate of return is so much higher than elsewhere. And so while I have complete respect for the silver tsunami, which is not only in the US, but in Canada, and I suspect in New Zealand too, what we really need to do is focus on our children. And whenever I go to Washington, D.C. to advocate for pediatric research, I realize I'm Canadian, but it's important to partner with our American colleagues south of the border. I always visit the FDR Memorial. And I think FDR had it right when he said that the test of our progress is not whether we add more to the abundance of those who have much, it's whether we provide enough for those who have too little. So the question I'll leave you with tonight is, are we providing enough for those who were born too little? And with that, let me thank you by saying that promoting brain health in the preterm newborn will undoubtedly provide new opportunities for better outcomes. And for the trainees who are starting to get involved, I'd highly encourage you to think of this area, because it's you that are really going to make the advances that are most impactful. I want to thank my colleagues at the University of Toronto and Sick Kids, at the University of British Columbia in Vancouver, and at UCSF for these ongoing collaborations, both across centers and across disciplines, are sources of support, but none of this would have happened without the tremendous engagement of our families and children involved in these studies. Thanks so much for having me.
Well, I'm sure you'll all agree that that was a most outstanding lecture by Professor Miller. So thank you very much indeed. That was absolutely terrific. So we do have time for questions. Please do wait for the microphone, and over to you. Margaret at the front here.
I had a question related to what you were talking about, the hippocampus and pain. Are the premature babies less sensitive to pain because of that?
Oh, that's a great question. So let me clarify that the main association is pain to the thalamus, the sensory relay station. And there's some suggestion that babies that are born preterm, it's probably the evidence is that it's bimodal. Some are more sensitive to pain later on. When you look at the vaccine studies, for example, they're more sensitive to the noxious stimulation, and others seem less sensitive. And so there's now some work that's trying to understand that both in experimental models and in human studies. I suspect that it's more complicated than just the imaging, and we're going to have to look to things like genetics to better understand that long-term experience of early life pain to subsequent experience of pain.
Question at the front. Oh, the one here, sorry.
So, thank you for your comments, and I don't disagree with the comments about sort of higher education and so on having an effect on children's brain growth now, but in the past that didn't seem to really apply. Up until the 19th and 20th century, up until about 1960s or 70s, people could walk out of school with or without the school certificate in New Zealand, get a full-time job, marry early, get a house, have children, who went on to tertiary education. So there seems to have been a huge shift round about that time between, say, a necessary connection with parental socioeconomic status and so on. And I wondered if, and also your stats didn't give any ethnic breakdowns. And I wondered if you had any comments about that shift and why now parental education is so much more important than it used to be in the past.
So that's an important question. I'm going to try and answer it a few ways. So the first is by saying Vancouver is an ethnically diverse community, and that the cohort of babies that I've shown you are representative of the Vancouver population. I won't get it off the top of my head, the different ethnicities. The issue of parental education and maternal education is that that's proven to be a robust marker of socioeconomic status. It's highly aligned to father's education, but mother's education is a more powerful predictor. It's also highly aligned to total household income, but many families don't want to disclose their income. So it's a less complete data set, which is why we use mom's education as the primary marker of socioeconomic status. The question we now have is, what is it about the moms? Is it just the education, or is it a reflection of socioeconomic status? And if we go back to the older literature, there's data from before this shift that you're describing, that socioeconomic status reflected by household income would be just as powerful. Now, I would have said that these data are focused on babies that are born preterm. But if we look at the Hart and Risley data, that was not babies born preterm. That was in the general population. And there's also sometimes a suggestion, well, that's a fixed quantity. Socioeconomic status, you're never going to fix poverty, so why are you even discussing this? Well, there's an amazing study that occurred in North Carolina. It was an education intervention study called the North Carolina Abecedarian Project, or ABC Project. And I didn't know about it until a few years ago when they published their 30-year outcomes. So going back to the beginning, this more or less randomized children in a disadvantaged area of North Carolina to a simple education intervention and easier access to nutritious lunch. Very simple. I think the whole study cost about $30,000. So it was very cost effective as an intervention. What they showed is that babies randomized to this simple education intervention had much better education achievement, more completed university. But I became aware of it because at 30 years, the babies in the adults in the baby intervention group had less diabetes, less heart disease, less metabolic syndrome. They were healthier adults, all from an area that you would have characterized as disadvantaged. So I think the question that faces us now is, what is it about the moms in that higher education group that we can now bring to policy and more widespread care of babies born preterm, or Hart and Risley's data would suggest otherwise, not just babies born preterm.
I have a question about antenatal steroids. You just briefly mentioned it. So I guess what I was told, I have a daughter who was delivered at 28 weeks in 87, and so I had a round of steroids. I was told that the steroids, are supposed to develop the lungs, but I also was told that it develops a lot of other things. So I guess my question is, what sort of influence does that have on brain development? And the daughter sitting next to me.
Great. Well, this is where the team at the Liggins might need to help me out. So the evidence is that it helps mature, brain specifically, it helps mature vessels in the brain that reduces another type of brain injury that I didn't discuss here called hemorrhage, or intraventricular hemorrhage, bleeding in the brain. But as you reduce babies' need, as you mature their lungs, then you mitigate that relationship between the need for prolonged ventilation and slower growth. We don't see negative consequence of the steroids on the brain. We see positive consequence. We think mediated largely through its positive lung effects. There are other types of steroids that are used after birth, and it's now widely contested which steroids and which regimens are best for the developing brain and for the outcomes of children, because those steroids are used to treat lung disease and to try to prevent lung disease. So this is another example of how do we learn to use the intensive care strategies at our fingertips in ways that promote most optimal brain development.
We've got time for another question, if there is one. Yes, just right behind you, if you wouldn't mind passing the microphone back. Thank you.
Hi. So you've been speaking a lot about how you as medical practitioners are researching and asking these sorts of questions. But for a kind of young couple who have just had a prem baby, what would you say to them?
I want to be sure that I'm explicit that none of this work happens because of me. It's because I'm part of a team that's not just neurologists or neonatologists or medical people, but people coming from multiple disciplines: psychology, nutrition sciences, rehabilitation sciences. So the outcomes of babies born preterm, we've got a whole group of babies who are thriving. And we now have fellows in the lab who have shifted their focus to trying to better understand who are the babies who are excelling. Right? I showed you in those distributions that there are many of those. So I actually find that this is a time of tremendous hope for babies that are born preterm, in part because of medical advances in the neonatal intensive care unit, but also as we better appreciate the importance of what happens outside the intensive care unit. So the advice I would have, or what I would say, is what I say to all of the parents I meet, which is love your children lots, read bedtime stories every night, and if you don't want to read every night, then the nights you don't want to read, then listen to some music together. Because I started asking, I don't have scientific data, just my experience, asking every parent that comes to clinic, this was in Vancouver, do you read to your child every night? And 2 of 10 said, absolutely. 6 of 10 said, well, occasionally when we remember. And 2 of 10 said, how do you expect me to do that when I'm working 3 jobs to put food on the table? And I think that's the challenge that we all need to take up when we leave here, is how do we make it easier for you to provide that environment for your child that was born preterm? You didn't say he or she? So that he thrives. The goal is that he thrives.
Yeah.
And I would be hopeful.
Well, I think that's a wonderful note to close the evening on. And I hope you'll all join me in thanking Professor Stephen Miller again for a fantastic talk.